Hey, Jan Paul here. I got some projects going on. I want to do a little cleanup on aisle 3. Recent project, a couple years ago, I posted a video about making a CNC turkey call. Oval shaped, lidded. I've got one here. It's kind of oval in shape, got standard sound holes, but it's made on the CNC, and the lid, it has a lid that nests into the body and just sits together. And people were asking me for dimensions, part numbers, part diagrams, everything that associated with this call. And I'd rather not give a program out. I wanted to go back and show I can give you dimensions on all the critical portions of this, but I'm not going to give you a program, so don't look for a link for a program. I'm not going to send you one if you ask me, but this video will go through how I designed the part, how I designed the fixture, and the critical points that make this call sound good to me. And so sit back and enjoy, and ask me questions in the comments. I'll answer as many as I can. But again, I will not send you files. Don't ask for the files. You can ask. I won't send them. But enjoy. This is the fixture that we've been talking about. 3 stations or nests. This being the first one. Rough blocks are put in here, and then subsequent, once they're machined here for the body and the lid, the body's flipped over, fits in this nest, and the lid is flipped over and fits in this nest. Some of the features of it, you'll notice it has pegs, 3/8 pegs on 2 of the corners, and those fit in corresponding holes that are drilled and made with the CNC, so they match exactly to the fixture. The other is I have some mounting holes, through holes on the blocks that hold that first block in station and clamp it in place. So those are just 1/4-20 press in nuts that fit on that. The other side of this, on the nest, for the body, it has a raised area in the contoured shape that I've designed that fits into the body of the call. I also have a hole here. If a part gets stuck on it, it's very difficult to get off without damaging the part, so I can pull the fixture and poke a dowel through there and pop it off. Haven't had that problem on the lids. Lids is a recessed area. Same thing, I just made that recessed area fit the part, and we have clamps from the side, basically just a screw block. I believe it's dovetailed in some way so it won't fall out of there, but that just clamps the part from the side. And so what this does for you, it gives you a known location to that corner that we were talking about. Once I place it on the CNC, if I find that corner, then I know where these parts are for the machine operations that you see. So this is kind of what I really wanted to design as a flip-flop part. I didn't care what it was. I'm looking at probably doing some spoons with the same type of technique, where I can machine it on one side with the CNC, flip it over, machine the other side, and make some consistent parts on the CNC. And I designed the part first, and then created the fixture, moving those parts to those positions in the different fixture positions. And so that way I have a known location for each part and tool path to a part design. So everything that you see outside of the part is part of the fixture. So I have some dowel holes that I'll explain later. There's this holding area that will be used to hold the block. So first thing I'm going to do is show you how I've designed the actual part, and then we'll move on to the fixture to finish it out. Get my mouse to work here. So the shape of my call, the working portion of it is just like a standard call. It is a round slate call. I use 3 1/4 inch slate from Pennsylvania. I get it from Brookside Calls online. They're about $3 to $4 maybe. The price may have gone up since I bought slate, but that fits in a little ledge that I machine into a block of wood. And then the area underneath, that's the mysterious part that everybody wants to know about, is how deep that is and how is my soundboard mounted and yada yada yada. So I will show you exactly what those dimensions are and show you how they're machined in the order that I machined. And then the other side of it is it's oval shaped. I made it oval shaped, and it has a little nesting feature, so the lid will match the oval shape of the call, and the lid will nest into the call and snap into place with a little magnet. So that's the odd stuff on my call. You can make them round using the same technique, and you can probably make them faster. I have done that. I've actually created other fixtures and done round calls as well. But this is what I'd like to do is just show you the different steps. This first station, I do it all with a 1/2 inch end mill, and I notate that it's EM on the end means end mill. You could do it with a 1/4 inch, it just takes longer. The first thing I do is I just take off 0.025 in depth. I machine off inside this area right here to make it all flat. And what I can do is I can give you a demo of it. Let's see, kind of get an angle here. And I can preview that visible tool. And like I said, it just shaves off just a very small amount just to flatten the whole area that I'm working in. So I'm working from a known distance. All depths that I'm giving you here are going to be from this top surface. So even this 0.025 is added in there if you're measuring to that degree. So just a few thousandths of an inch just to flatten it, it's all in there. So that's that one. The next one is we're making let's see, this circle right here represents the outside dimension of the slate. That is 3.25 for the slate that I ordered. And then inside of that there is a little lip that supports that slate. So on that slate nest, it is another 0.2 down from that surface area that I just machined. So total distance down to the edge of that slate is 0.225. So that is what we're going to see next. Visible toolpath, go to 3D. I will, the slate nest, I'll preview the visible. And all it does is step it down. That is exactly where the slate will seat into the part. So that's what we're seeing now. And then this is you could do this next 2 steps all together and clear out the material inside the call. I separated it because I was having some chip out on the tops of these where the soundboard rests. So I basically machined down to those, cleared those out, and then I did the rest of the machining after that, and I'd had less chip out. So you can try it different ways, but that's how I ended up doing it. If you watch that on the previews, it looks something like this. I'll do both of them at the same time. Visible toolpath. So it machines down to the top, and then it machines out, and it just clears out the material inside that lip and leaves those soundboard rests. So this is the, if you look at that, I'm going down to 0.6 from the top of the part again. 0.6 is the depth to the top of these rests, and then the chamber, the rest of the chamber that takes it all the way down to the bottom is 0.7. So it's only 0.1 inch between the bottom and the top of the rest, and the slate is 0.2 from the top. The rest of there's still material here on the bottom that makes up the caul. I typically have that less than 1/8 of an inch at the thinnest point. I leave it about 3/8 thick because I contour it in future steps. But you can make that material as thin as you want. It does affect your caul sound, how thin that material is and what the material is. So the wood that you choose matters in the sound of the caul. I make a lot of my cauls out of walnut because that's what I have. It's really beautiful wood. Some of the best cauls I have ever made were with hard maple. It's really bright. It's horrible for a caul to be that bright, I would think, but people that use them love the sound of the hard maple cauls. So there you go. Everything else after that is I make a locator tab here. We'll preview that, and all it does, missed it. There it goes. It makes this little nub right here that the lid fits into. The outside of the part is just cutting out the part. I leave this about, I'd say 1/8 of an inch around the thickness here. It gets a little thin sometimes with sanding. This will leave a kind of a rough edge that you have to sand down once you put the parts together. You'll see that in my other video, but this you can get this too thin and it will tend to crack if you get it too thin. So leave yourself a little material, play around with that dimension, how much material you leave there to work with. And that's pretty much it for the first station. If you look at them all together, we'll preview all two paths together. Flatten the surface, nest down to the rest, cut out the rest, location, and the outside. That's it. That's the majority of your caul. You'll notice that the part is not removed from the part. I don't do tabs or anything. I don't cut it all the way through. This is cut out of a block. It's not out of a solid piece like this. So it'll leave just some small portions of that block left, and I cut that on a bandsaw and then fit them together and then sand the rest close up to where they're mating together. You'll see that in the other video as well. So that is the first station combined, and probably the one that takes the longest out of all of them. So now we've finished the inside of the body of the caul, and what we're going to do now is flip it over, and we've got the second nest or station of this fixture. Same reference point, so it's located from the bottom left. This is the outline of the part, and then I've drawn in the sound holes for this part. What you don't see is I've also got a 3D contour that I designed, and essentially I took this outside dimension of the caul and I went into my modeling software, and I forget how I did this to tell you the truth. Two rail sweep or sculpted, somehow I created this 3D shape, and what it looks like is just that. It's basically takes that outside edge and just rounds it off overall, front to back. So it's evenly contoured across that shape. I've tried it a little sharper with rounder edges, but what happens is you get into that caul area inside the caul will come through, and if you make this too thin, you end up having really thick material out here and really thin around the edges. So with it fairly flat like this and contoured, it's still a nice shape, but that is the fancy part of this. And to tell you the truth, that takes the longest time to cut this portion is making those contours. So I do both of these tool paths with 1/4" ball nose bits. Even the sound holes, they are 1/4" ball nose. It takes you could do it much quicker, cleaner cuts on these sound holes with a end mill. Just a square end mill, 1/4", but I don't want to change tools between this. I want to do it all in one tool setting. So I do the 3D contour and the sound holes both with the same bit. What that looks like is, I get two. Where'd they go? I preview both. There you go. Just looks like that. There we go. Reset. So first thing I do is that contour. It slowly works its way out. You'll notice it leaves little lines in there in the step over. You can make that step over less and get less lines, but it all comes out in sanding. You will notice if it doesn't come out in sanding, you will see it in your finish. If you get it down, if you see any lines at all when you're doing your final sanding, it will show up when you put your finish. Don't think it'll cover. You might as well just take it back down a few different drits and get it back to smooth. The downside to this design is there's a lot of hand finishing to this. It's hard to finish all those contours on a machine. So you end up hand sanding a lot of that stuff out. So go heavy first, work your way down, make sure you get all the stuff, the heavy stuff out with the heavy grit. That is that step. That part has already been cut out in that previous station. So this contour will take it down to the outside of the part and leave you with a completely contoured part without any flashing or anything left over. So that is the second station. Okay, what I'm calling the third pocket here is actually made in the very first pocket again. Same fixture, same holding mechanism, same location, same bat channel. But I've moved some different stuff in here. I have the overall shape of the caul. I have the dimensions, the shape of the location still in there. And I really only have 3 cuts on this. All of them are made with a 1/2" end mill. And they are just deep enough. The very first one is, again, to face off that the top of the wood. I'm only going down 0.025, again, just to give me a nice flat surface to work from. The second one is the locator depth. This is how much it's going to sit down into that pocket where the slate and the location is, and that depth is, again, 0.105 from the top of the block. So the last cut is this path. Let me turn the other one off. It's confusing now. This last cut, again with a 1/2" end mill, just runs around the outside edge of the lid and cuts out the lid from the block that it's in. So what that looks like if I go, here we go, those are my tool paths there. I can preview those tool paths. It'll go pretty quick, and it goes real quick because I haven't reset it. Preview all the tool paths. Nice flat area. Sets it down. Cuts the lid out. That's it. So those are your 3 tool paths for the lid in that first nest. And now that part is free to flip over. So we will open our 4th station, 4th pocket. Bam. There we go. And you'll see this has the same contour that I put on the underside of the body. Same deal. If I look at it in 3D, it looks just as cool. It does really. If I get it over here. There we go. So that's our contour, and I'm not sure what that. Oh, that's it. I did another area. I can actually recess this in there, and yeah, I actually did that to screw. I screwed some parts up and wanted to make a different shape. So, but that's all I do on the underside, on the top of the lid most times, is just contour it. So if you just look at that, there you go. That is the entirety of the tool paths to make this call. So here's our fixture program, and again you'll recognize a lot of these are from the part programs I had before. I just brought them all together into one drawing, one fixture. And you'll notice again it has 3 stations, 3 nests. That this first one you'll see I don't have all the part drawings in there. We're not machining that stuff. We're just basically opening up the area that a block would go into. Everything else you see in here I used to make another fixture to be able to drill a hole for the magnets in the body and in the lid. I have a separate fixture I created for that. So that's all you see in those lines. But the main one to actually build this fixture is the outline of the fixture itself. And I drew it once, copied it to the other locations, and then located the other tooling drawings to those locations. These little lines that you see here are just some that I use to find that center point and keep it consistent between all the different nests. You'll see in here I've actually drawn in the areas that I machined to make those slots for the clamping mechanisms that I installed later. But these all, if you look over here on this side, the tooling on this is it basically, there's those nest clamps, the posts that I did. Those posts go down. I machine those down into the table itself, so I can plug that whole fixture into the table in a known location with holes made specifically for that fixture. Let's see. This is again the magnet jig body that I created, another jig to be able to drill those with a hand drill. But everything else is pretty. This dimension is the same from the drawing of the parts. I had to flip them, I believe. No, I didn't. It's exactly the same. So from where I machined it on the part, so it will fit. I may have had to relieve that, do a what's the word? I may have, yeah, I did an offset on it to make it a little bit larger so it would fit down in there. And then a little bit smaller on the lid to be able to fit up into there. Those are actually fairly tight. You'll notice on the pictures previously in the video of the fixture, there are some holes that I use. If I get a part stuck in the fixture, I can actually poke a dowel up through it and pop it out of there if it gets stuck on there without tearing it up. But that's pretty much the whole basis of the system. It's not anything proprietary. It's stuff I picked up over the years just watching real machinists do this. It's doing nice repeatable work is about having a good location of material, sturdy work, and without chatter, without breakage. You're exerting a lot of force on this wood, so you don't want it moving around. So designing a part that lends itself to being held firmly while you machine it and do everything that you want to do. It was very satisfying to make a fixture specific to this part, and I highly recommend you do your own. There's nothing that is rocket science here, but just make something interesting and have fun with it. Well, I think that's about it. I've really enjoyed doing this project and kind of wrapping it up with the video on how it's designed. If you have any questions, leave them in the comments below. If you have projects that you do, leave links to them below. I would love to see what you've learned and what you're doing. So, thanks. Jan Paul out. So I hope this